Welcome, dear audience, to another Agora online event. Today's topic is Sources, Transport, Applications to Insights on Hydrogen. I'm Nicola Bock. I'm Head of Events at Agora Energiewende and your host today. During the next 60 minutes, we are going to present a brand new impulse paper, which has just been released literally a few minutes ago on our website. It's called 12 Insights on Hydrogen. And I hope it will be helpful for anyone out there thinking about which sources to use, how to transport and how to store hydrogen and what have you. And the good thing is we have the main author of the study today on our podium, and you'll get a very focused and clear presentation of those 12 insights on hydrogen. And of course, you can always read the publication afterwards, but you get the main insights already during the next 30 minutes presentation. And my colleague Matthias is already posting the link to the impulse paper into the chat. So if you're curious, go there and download it. And after the presentation of the author, we will have a comment of a member of the National Hydrogen Council of Germany. And afterwards, there's time for a Q&A session. Around 20 minutes we've reserved for that. And we hope that we can address many of your questions, put them into the Q&A box, and we will browse through them. And let me see how many we are, 201, but there's still people entering the room. So looking at the time, let me ask my colleague Matthias Deutsch, who is program lead of hydrogen work at Agora Energiewende, and is going to prepare the ground for you for the presentation that we will hear in the next 20 or 25 minutes. Matthias, I hand over the microphone to you, and I'm very curious because I haven't read the study myself, so I can't wait to hear the 12 insights on hydrogen.
Thank you, Nicola. Thank you very much. Welcome, everybody. Welcome from my side. As Nicola said, I'm heading our program on hydrogen, and we have created this program to acknowledge the complementary role that renewable green molecules will play, in addition to green electrons, on our way to becoming climate neutral. And the details of that role are the subject of controversy. Some demand very many molecules for the future, others call for more focused use of hydrogen. And we at Agora have proposed a notion of no regret hydrogen for those applications that really need it to become climate neutral. And earlier this year, we have published a study on no regret hydrogen infrastructure, another one on making renewable hydrogen cost competitive. And we also collaborate with our industry team colleagues who are working a lot on greening steel and, for example, carbon contracts for difference as an important policy instrument. And as Nicola just said, today we have released our 12 insights on hydrogen. You can find the link for download in the chat. And those insights are meant to be a guide to navigating the hydrogen wave towards sustainable applications and supply. And we are glad to have Gniewomir with us, Gniewomir Flis. He's a project manager hydrogen at Agora Energiewende. He's the main author of the impulse paper that you can download. He'll present the insights, and after that, Kirsten Westphal will comment on the paper. Kirsten is a member of the German National Hydrogen Council. She's a senior associate at the German Institute for International and Security Affairs. And as she just told us, in the coming years, she'll actually work closely with the H2 Global project, which is kind of the German import scheme, an idea of how to import renewable hydrogen to Germany. And with that said, as an introduction, again, welcome. Thank you very much. And Gniewomir, up to you to present us the insights.
All right. Thank you very much for this lovely introduction, Matthias. So everyone, I hope you're ready. I'm just going to share my screen quickly in a second. All right. So is this working well?
That's fine.
Yeah, thank you.
Yes.
All right, so there we go, 12 insights on hydrogen. First, I'd like to start with a little context setting. So Matthias was talking about the importance of the debate that's happening right now. And for one of the first messages I want to say that is not an insight, but sort of the context setting message is that hydrogen is crucial for mitigating emissions in the European Union and even in the world. And here is a chart of the expected emissions reductions from different measures that's been presented by McKinsey. And we note that hydrogen is right over here, and by 2050 is actually the second single biggest measure we can take to abate emissions to the tune of 10 to 15%. So it is clear that hydrogen will play a role in climate neutrality, which is why we're all here. However, hydrogen poses certain problems, especially the renewable and clean sort of hydrogen that we want to have to achieve these emissions reductions. And here a graph of impact of carbon pricing on economics of hydrogen and natural gas in 2030. And we see that hydrogen is clean hydrogen or even fossil-based hydrogen with carbon capture is not competitive with unabated hydrogen or worse, natural gas, which it is meant to replace. And this is at a carbon price, this happens at a carbon price of, absent of a carbon price. The picture changes slightly when we achieve a carbon price of 50 euros, which is a little bit less than what we have today, but still renewable hydrogen, which we expect to have an average price of 110 euros per megawatt hour in 2030, is far away from being competitive with either fossil-based hydrogen with carbon capture or unabated hydrogen and natural gas. And the picture only changes when we achieve carbon prices of around 300, 400 euros per ton. So it is clear that what is needed for hydrogen to take off, especially renewable hydrogen, is more policy support in addition to carbon pricing. So that's the first issue that is presented by that hydrogen is facing. The second issue is the opportunity cost of producing green electricity. And green electricity can be used to decarbonize through direct electrification, or it can be used to produce hydrogen. Now, depending on the net zero scenario you take or the agency you like most, there is a number of estimates of green hydrogen demand which drives the need for green electrons. But by 2050, roughly speaking, we would need to double our electricity system globally just to produce enough green hydrogen. That's not doubling the renewable system, that's doubling the entire global electricity demand, which is substantial, and indeed it poses an important opportunity cost. So with these issues in mind, we set out to navigate the uncertainties of the upcoming hydrogen economy and sort of try to figure out which uses for hydrogen are the most important, or at least pose the least opportunity cost and make the most sense from a policy perspective. So without further ado, here is the main body of work, the 12 insights on hydrogen. And the first insight is that the role of hydrogen for climate neutrality is crucial, but secondary to direct electrification. And analysts agree, but not all lobbyists. And in this graph, on the left-hand side, we've taken a number of net zero scenarios that deal with European Union, specifically actually 1.5 degree compliance scenarios. And you can see that most of them, apart from the LCO net zero scenario, are in fact in large agreement with each other. The absolute level of demand by 2050 of hydrogen is roughly equal. And what we see also, there's pretty broad agreement when it comes to how much hydrogen will constitute in terms of final energy demand, which is between 15 to 25%, or as we call it, roughly 1/5. Looking deeper into this graph, we looked at the variability across the different scenarios. And we found out that hydrogen is poised to play an important role in industry, and that most scenarios agree that it has an important role in transport as well. Though in transport, there is one big outlier, which is driven by a larger use of fuel cell electric vehicles. Then we found a substantial amount of hydrogen used in power and a rather limited role for it in building heat, or at least the least of all sectors, which led us to propose sectors where policy should focus. And we call these, not sectors, we call these actually no-regret applications. And within these, from this matrix that we have in front of us right now, we see that hydrogen is truly cross-sectoral, spanning industry, transport, power, and yes, even the building sector. But the no-regret application, but the no-regret applications in each of the sectors are important because that's where policy support should be targeted. So just to give an overview, we believe that no-regret applications are reaction agents in industry or feedstocks, so non-energy uses. We believe that green hydrogen has an important role to play in synthetic fuels for long-haul aviation and maritime and shipping, and for power system backup on a seasonal scale. We also believe that hydrogen might have a very limited role in building heat, but not in individual buildings in the sense of boilers or fuel cells, but rather in district heating systems. So this is an overview of where of our no-regret applications and where we believe policy support should be focused on, which leads us to our second insight, which deals with infrastructure. We should anchor hydrogen infrastructure around no-regret industrial and power demand. And here you can see there are two maps in front of you. On the left is a map that Agora, together in A3 in February this year, released as part of a no-regret hydrogen study, where we looked at industrial hydrogen demand in the future and tried to figure out what is the most sensible, robust hydrogen transmission infrastructure that could be constructed based on this demand. And this is roughly in line what the Guidehouse European Hydrogen Backbone Study sees for 2030. At least two of the regions, which is in Northwest Germany and in Spain. So these are early opportunities to start rolling out hydrogen pipelines and see whether the system works and whether they are as cheap as the gas transmission system operators would like us to believe. Now, when we talk about pipelines and when we talk about renewable hydrogen, it is there's an element that is often omitted from this part of the story, and it doesn't get much love, and it is storage. And what we found is in insight number 3 that we're going to need a significantly greater amount of new large-scale geological hydrogen storage. So let me walk you through this chart real quick. On the left side, the pink bars show the current gas storage potential that we have today that could be theoretically repurposed to store hydrogen. And the 2030 hydrogen storage demand is significantly lower than that. So yes, we have current facilities that could be theoretically repurposed, and frankly, we should start working on them because it takes about 10 years to repurpose and to develop such a facility. But by 2050, we found a substantial shortfall of gas storage needed. And because of these long lead times, we need to start thinking about developing new salt cavern storage now. At the same time, of course, current gas storage is used for gas storage. So it's not clear we can be repurposing all of it in the next decade. So the message is start thinking about new gas storage now. And why do we focus on salt caverns? Well, there is a very good reason for that. This will be a graph of levelized cost of hydrogen storage in just a second, but first I'd like to introduce two dimensions to you. The first one is the length of the storage, and at the top you see we measured it in years and months and weeks and in days. And the second dimension here is the frequency of cycling of this storage. Now, when we look at the economics of different storage options, this is what they look like. Right away, you can see that the salt cavern storage is amongst the cheapest, right away there with gaseous hydrogen storage. But when we talk about these no-regret applications, and I mentioned this before, we view seasonal power storage as one of them. Seasonal power storage means storing hydrogen for weeks, months, and here salt caverns are the cheapest option. Even though gaseous storage is just as cheap, it's just inappropriate for the scale and the length of the storage that is required to firm up a renewable-based power system or to back up, to provide some buffer for industry. Now, I talked a lot about the different no-regret applications to focus policy support on. Now I'm going to walk you through the policy instruments that we need to support renewable hydrogen in these no-regret applications. And then there are three dimensions to this. So first one is the sectoral focus. At the very bottom of this graph, you have industry, transport, power, or cross-sectoral applications. Then the second dimension that we think about is whether the instruments are demand-focused, and within this demand-focused instruments, there is a subset of instruments that leads to the creation of lead markets. These actually focus on these instruments will rather focus on a rather narrow niche of hydrogen, or currently narrow niche of hydrogen-based products, not just hydrogen demand, but perhaps demand for hydrogen derivatives. This can be things such as steel or ammonia. And then there are, of course, supply-focused policy instruments. And the third dimension of this graph is the time horizon. And we differentiate between two periods: the near term, over the next decade, where we focus on supporting hydrogen market uptake, and then we think about 2030s, which is the longer term game, which is where we think about establishing a mature, full-fledged hydrogen market. Now, there's a number of different instruments we can come up with here, and this is the menu we've come up with. Now, I don't want to spend too much time on all these instruments, but I just want to throw a shout out to some. For instance, we see carbon contracts for difference costing between 0 to 10 billion euros per annum for the whole of the European Union in supporting the steel sector. And we see power to liquid quota for aviation, 10% quota costing between 10 to 14 billion euros per annum in subsidies, coming to 10 to 24 billion euros per annum in subsidies just for these two instruments, which frankly in the grand scheme of things is not a lot. But if you'd like some more details on these instruments, we have a publication that Matthias alluded to earlier, the publication that was released, I believe, in June, called Making Renewable Hydrogen Cost Competitive. So if you'd like to find out more about these, I suggest you check that publication out. So now we've talked about the policy instruments for supporting renewable hydrogen. I'd like to spend a minute to talk about applications where hydrogen doesn't make sense and which the policymakers should avoid. And one of these applications is hydrogen use in households. And we believe, and the gist of insight number 5 is that there is no credible financing strategy for hydrogen use in households. And why is that? Well, if we are to meet our targets of if the European Union is to meet its target, its climate obligations, then it foresees a 42% decrease in emissions from the building sector by 2030. Now, some proponents of hydrogen have said, well, blending can help achieve that, and we don't really see blending as a realistic way to achieve this target, because the blending limit is approximately 20% of hydrogen by volume in the gas, which leads us to a 7% emissions reduction, which is very far away from the 42% needed, but it increases the price of gas delivered to the customer by 33%. In any case, blending is insufficient. What about a bigger blending effort, or rather, whether this is a physical blending or virtual blending? Well, achieving the 42% reduction would require essentially tripling the current gas price paid by customers. This is likely to prove very politically difficult, and it would have disastrous implications on some poorer households. So we don't really see hydrogen in household heat having we don't see a financing strategy that works out for introducing hydrogen in household heat. And because of this, this has important implications on the distribution system operators, which is the subject of our insight number 6, that gas distribution grids need to prepare for a disruptive end to their business model. Now, just recently, I spoke a little bit about the need to phase out gas. The European Union mix scenario, which is from the Climate Target Plan Impact Assessment, foresees a total reduction in gas by 34% over the next decade and a 96% reduction by 2050. In buildings alone, over the next decade, we see a 42% reduction, which I've mentioned, but then we see a further totaling to a 68% reduction by 2050. And you can see that hydrogen or e-gases make a tiny proportion, or rather, well, most of that, but a tiny proportion of what was used in 2015. So gas distribution grids, for whom retail customers are a big part of their business, need to prepare for disruption. And another reason for this is that, or rather should I mention, low pressure gas distribution grids. Some gas distribution grids can actually change their business model a little bit, and I'll explain this through the example of system efficiency, considering first hydrogen boilers. So 100 kilowatt hours run through electrolysis and then distributed to households will provide 61% kilowatt hours of heat. But the same 100 kilowatt hours run through electrolysis, again to hydrogen, but then used to power a hydrogen turbine or fuel cell, and then that electricity from the turbine or fuel cell is used to run a heat pump, can provide between 63 to 125% kilowatt hours of heat, depending on the coefficient of performance in the heat pump, which in turn depends on the outside temperature. So at the very worst, a hydrogen turbine is just as efficient as a hydrogen boiler, but at the best circumstances, or rather, sorry, not the best circumstances, but in average situations, it will be twice as efficient. And the picture is even greater if we cut out the hydrogen turbine. Now, we see a role for hydrogen turbines in protecting, in firming up the renewable-based system when the sun is not shining or the wind is not blowing, but there will be also significant periods where electricity will be able to be fed directly to the grid. And in these cases, heat pumps are between 2 to 4 times, even almost 5 times more efficient than hydrogen boilers. So from a system perspective, it really does not make sense to be introducing hydrogen to households, which means strong disruption or dangerous disruption for distribution system operators, and they should be thinking about new business models. On to Insight 7. Now, distribution system operators might be thinking about new business models. Maybe they will be supplying fuel cell electric vehicles. But as this IEA analysis of different manufacturers of electric vehicles, specifically in this case of the trucking sector, demonstrates, the imperative for introducing hydrogen into mobility is weak, even in the, well, is weaker than batteries, even in the most proposed, even the most proposed mobility sector, which is the heavy trucks. So approximately 80% of all trips, according to this graph, will be made through battery electric trucks. This picture, even this ratio even widens when we consider the rivalry between electric cars and hydrogen cars. Now, so yeah, this talks a little bit of the potential. This sums up the potential of gas distribution system operators and the dangers that they're facing from the phasing out of low gas distribution networks from the household perspective, but also from the transport perspective. Now, in Insight 8, the subject of Insight 8, we see that each gigawatt of electrolysis must be backed by 1 to 4 gigawatts of additional renewables. And this has very much to do with the number of full load hours that these electrolyzers have to run to be economic. And at least for the next 10 to 20 years, we see 4,000 full load hours per year as being the golden standard to reach, which will take between 1 gigawatt of offshore, 2 gigawatts of onshore wind, or 4 gigawatts of solar PV. And this is our sort of rule of thumb rather than imposing, this is a rule of thumb to policymakers considering the rollout of gigawatts of electrolyzers in their strategies. Right, and we see hydrogen trade as being rather regional. Shipping hydrogen is more expensive than pipes and cables. Now, in this graph, I'd like to start with the cost of producing hydrogen in Iberia, which is the lower bound of this band, and the cost of producing hydrogen in Germany, which is the higher band of this range. And you see there's quite a substantial difference. If you were to import hydrogen to Germany from Iberia, you have two options: either build a new pipeline or build or retrofit an existing one. In any case, under both options, a pipe sourcing hydrogen from Iberia to Germany makes a lot of sense. It is quite cheaper than producing locally, at least in 2030. When we consider a cable as a competitor to the pipeline, it is slightly more expensive, but a new cable is, well, one could argue that a new cable is competitive with a new built pipeline. It's only the retrofitted pipelines that are really cheapest, but they pose a problem in terms of if you still need the pipeline to pump gas for a few years, and if you don't have a parallel network, you are only faced with one choice: to build new infrastructure. And there you have a little bit of leeway whether you should build a pipeline or a cable. But the biggest takeaway here is that if you want to ship hydrogen, that's going to cost you, and it might even cost you more than producing it locally if the hydrogen you're importing is imported through ammonia and then cracked back to hydrogen. On the other hand, if you're importing ammonia for the sole purpose of using this ammonia, it does make a lot of sense. But the second you start converting it back to hydrogen at the end point, it becomes really expensive. So it is in the interest of European countries to build hydrogen networks, whether that's electric or pipeline, as quickly as possible. And this was the picture for 2030. Now on the right, you have the picture for 2050. Of course, the levelized cost of hydrogen drops as electrolyzer economics improve and as renewable power economics similarly improve. This makes local production slightly more competitive than it was before, but shipping is still shipping hydrogen through ammonia and then cracking it back is still the most expensive. So any long-term strategy must rely on pipeline or cable transport from good renewable countries. But, and this is subject of insight number 10, actively securing public acceptance is crucial for Europe to reach its hydrogen potential. And we already see in 2020 we've had approximately 600 terawatt hours of renewable electricity produced across Europe, and to decarbonize fully the power system, that number has to triple by 2050. But if we also want to produce green hydrogen, all of the green hydrogen that we need within Europe, we would have to double that amount of renewables still. And just to give you a sense of scale, essentially this means that we have to double the rate of renewable deployment over this decade, and then yes, double that again in the decades to 2030 and keep that rate of deployment between 2040 and 2050. One way to get out of this conundrum is, and to keep industry competitive, is to import cheap hydrogen from neighbors whilst importing synfuels from a global market, which would allow Europe to decrease the regional hydrogen demand it needs. And the reason why we should import, now I've talked a little bit about shipping before, where it's uncompetitive if you are importing hydrogen, but if you're importing synfuels for the purpose of using these synthetic fuels or chemicals, should I say, then that becomes a very attractive proposition. For instance, you can see that Germany here could do well to import ammonia from, most other countries. The economics of it becomes even more attractive when we talk about sustainable carbon-based molecules such as methanol, and is even more important when we talk about synthetic Fischer-Tropsch fuels such as e-kerosene. So to sum it up, the hydrogen import market will be regional, but synfuels and synthetic chemicals will be part of is an important global market opportunity. And then finally, I'd like to touch upon a topic that was very controversial over the past few months. Now, I've alluded to the issue of securing public acceptance for greater renewable deployment within Europe. But what happens if we cannot secure this acceptance within Europe or even somewhere else? Well, the subject of insight number 12 is that we should remain open to the idea of hydrogen from processes involving carbon capture, but we must combine it with strict safeguards. And this graph is a little bit complicated. I'm not sure why it's not animated, but let's start with the bar on the left. So on the left, we see the life cycle emissions estimated if you take a methane leakage rate of 3.5%. And you can see this bar is almost as tall as the fossil fuel comparator from European Union Sustainable Finance Taxonomy technical criteria. So it's almost as bad as unabated hydrogen if methane leakage is high. And this was the subject of the Howard and Jacobson paper earlier this summer. However, if you take the global average of methane leakage of 1.5 degrees, then the picture is not so bad for blue hydrogen, but it still goes past the 70% reduction relative to fossil fuel comparator that is deemed as sustainable through the current EU taxonomy draft. Clearly, a global average importing methane to make blue hydrogen from using a global average of suppliers would still be quite bad for the climate, which is why we argue the EU should strive and should push actively and should actually set the standards on methane leakage, on methane leakage and on carbon capture. And at 0.2% methane leakage, which is the third bar, the emissions from blue hydrogen are quite low, and I would even compare them to running an electrolyzer based on an electricity system with 100 grams of carbon dioxide per kilowatt hour. So it is possible. One thing should be made clear: blue hydrogen is not sustainable in the long run, but it can be useful as a way to bridge the gap in the next decade or two, if it is combined with strict safeguards of at least 0.2% leakage and at least 90% carbon capture. So that concludes really the presentation. At the very end, I'd like to give a shout out to all our other publications on climate neutrality, hydrogen and industry. And here are some examples. I've mentioned the Making Renewable Hydrogen Cost Competitive study. Prior to that, we had the No Regret Hydrogen study, which dealt with infrastructure. And we have some really interesting studies from our industrial colleagues, from our Germany colleagues, with the Towards a Climate Neutral Germany study and Breakthrough Strategies in Climate Neutral Industry in Europe. So yes, that concludes the presentation. Thank you very much for your attention. And I encourage you to actually look at the study because it has a few graphs that I wasn't able to cover in this presentation, which I find equally interesting.
Thank you so much, Gniewomir, for this initial overview. In fact, yes, there are more graphs. Same feeling here. And now we have Kirsten for her perspective. Kirsten, in the grand scheme of things, with your particular focus on international relations and geopolitics, what do you make out of this, what you've heard here?
Thank you, Matthias. And I know I'm in between the questions of the audience and yeah, the presentation with my comment, but I really join Matthias and Gniewomir. Please read the insights. It's an excellent in-house paper and very rich in illustration. So you really get a very good idea. The first point I would like to make is that, of course, it's very clear that we are doing hydrogen not as an end in itself, but we are doing that to achieve carbon neutrality. But that does not mean that we are getting rid of the other ends of the strategic triangle. So energy security is still there, and we are realizing that, I think, these days very clearly. And this is why I very much like that the paper sheds light on the issue of energy security and H2 in the power sector, as giving stability, plus also really putting a spotlight on storage, which is mostly forgotten or in many publications not mentioned. The other point I would raise is competitiveness, because it's there in many places in the text, but I think it's a huge challenge for the European industry if we follow a very rigorous path and other countries don't do that. And I think it's also an important point to mention that to me, at least to me, hydrogen is not only about an energy transition, but it's really a part of an industrial revolution. And as such, also part of a Green Deal. And this is something we have to keep in mind. My second point is we are not starting from scratch. So of course, target scenarios are very valid in their point, but we have to think through where do we stand and what is kind of the situation in the market. And Gniewomir rightly said that we have to navigate through uncertainties. And to me, one of the major uncertainty is really when will we see, disruptions of the past dependencies, because we have social economic inertia. We also have really political path boundness. And it's not just, to me, the necessity to change the toolkit, but maybe rather really to create a new hydrogen toolkit, at least in the European Union. And it's, of course, the whole question of how quickly the political levels will address the issue and kick off implementation. And this is what I really very much like also of the report. The report talks about no regret measures. That is extremely helpful, but I think we could also work on, and this is what I would urge the colleagues in Agora to do so, we need to think about the steps in between. What are enabling transitional steps? And I think therefore your 12th point of mentioning blue, maybe also turquoise hydrogen is extremely important, because then we also talk about CCS, which I think is a part of the picture of decarbonization. And also the question, who finances the transitional steps if these are a discontinuation model? I think this is something we have to debate. And I'm very grateful that you mentioned, Gniewomir, Matthias, the big question marks around the heating sector, because you can think about all measures of energy efficiency, but the big question is, can you implement them as quickly as it's needed with regard to the lack of material we're experiencing right now and skilled workers. Final point is, of course, we have to think about the geopolitical and geoeconomic side of the story. This is why I mentioned it's also part of the Industrial Revolution. And what I really like of your graphs is that it's so tangible that the hydrogen revolution will change our geographies, and it will matter on the sequences and the time horizon. So the unevenness within countries, within regions will really change, posing an issue to not only just transition, but also to cohesion of political entities. And I also fully agree that we have to think around concentric circles, at least in the EU, thinking about the EU, how to kick off infrastructure and the market. And the big challenge is really to kick off and address the chicken and egg problem within the market rules that we're having in the EU. But really to think around concentric circles in the EU plus the neighborhood, and in parallel, kicking off, as you said, a global market for synfuels, ammonia, and so on. But big urgent, read the report, and many thanks to both of you.
Thank you very much, Kirsten, for those kind words. We now have a range of questions. I can tell you, I tried to cluster some of them according to some kind of logic, and we can't start with, I think, the initial ones chronologically, because the clustering is very much around certain topics. So I think still starting with the rather earlier question, let's start with some basic cost questions. When we talk about cost, one of the questions, early questions, looking at this renewable hydrogen cost and the carbon pricing, one on slide 4, the question is which prices of renewable electricity were considered in the diagram, which compares green to blue to gray. What are the underlying renewable electricity prices?
That's a good question, Matthias.
Maybe I could answer faster if that helps you.
Yeah, maybe you could answer faster.
Since this is from our preceding publication on making renewable hydrogen cost competitive, I urge you to look that up in the publication. We have a range of different studies evaluated, and most of them take, to my understanding, LCOE for wind, solar, for example, Hydrogen Europe or Blue or Guidehouse or others, and then take those LCOE to derive cost of hydrogen. But I would urge you to look that up again. I think this is what we have. Here's a second question. What is the electricity source for renewable hydrogen? For example, solar, hydro, are you also considering green electricity from the grid? If yes, we need to pay grid fees, guarantees of origin, and this may make the green hydrogen uneconomical. Did you account for that? Maybe you want to comment on that.
Yeah, I suppose, and this was the subject of insight number 8, yes, that each gigawatt of electrolysis must come with 1 to 4 gigawatts of additional renewables. Really, in terms of additional renewables, we only consider offshore, onshore wind, and solar PV. We don't see much hydro being built in the future due to its environmental impacts. As for grid-connected electrolysis, I suppose in the initial stages, it will be, there's a big debate on additionality happening at the moment, and a lot of it sounds very restrictive to grid-connected electrolysis. So I don't see it playing a large role in the initial scale-up of hydrogen.
Maybe to follow up on this very technical question, I think exactly on Insight 8 on the additionality, how is accounted for the simultaneity of power generation by the renewable? For example, if 4 gigawatt solar PV is coupled to 1 gigawatt of electrolyzer capacity in sunny conditions, this will lead to high curtailments. Are measures to avoid this assumed, such as storage with batteries or coupling solar and wind? How is this reflected?
Yes, I mean, that would be coupling to storage would be the ideal case. But I suppose the larger idea is to have, is not necessarily to couple the 4 gigawatts of solar directly, but to have as a grand strategic vision for every gigawatt of electrolysis should have 4 gigawatts of solar, not directly connected through cable, but deployed somewhere so that the energy is produced. How it gets used in the interim is for the sort of system balancing folk to find out, right?
Yeah, let me continue with storage, which also came up several times. Somebody's asking for clarification. The cost of storage would in most cases almost double the cost of green hydrogen, adding, and then he quotes, 2 to 4 euros per kilogram on top of a 2030 green hydrogen of maybe 2 to 3 euros per kilogram. So is that the kind of what we have to add for cost of storage?
I mean, we do sort of see these costs in terms of rock caverns or in terms of storage as ammonia or liquid organic hydrogen carriers or even in depleted fields. But when it comes to salt caverns, there is evidence that we can get very low costs of storage, especially if these salt caverns will be cycled frequently and if they will have long life.
And staying with the storage issue for a second, why did you not consider other energy carriers as long-term storage media for like synthetic methane, methanol, synthetic liquid fuels? Hydrogen could be removed from them via reforming, and then CO2 released could be retained for repeated use in a closed carbon cycle.
I mean, this comes back really to the point about blue hydrogen. And do we want to be storing methane, which has a really high global warming potential? And then, the whole debate about carbon capture and whether we can get it to 100%. As I mentioned, we don't see blue hydrogen as a fully sustainable solution. We see that could play a supporting role in the transition phase, but we definitely do not want to be promoting these synthetic fuel routes. And another point about this, if you need hydrogen and if you're taking hydrogen and storing it as a more complex molecule and then reforming it back to hydrogen, the overall round trip efficiency is just so much more complex and consequently expensive than simply pumping this hydrogen into a salt cavern. So we did consider it in Insight 3. In the report, you can look at the graph that the survey has been done by Bloomberg. The cheapest levelized cost of hydrogen storage is through salt caverns, and that is why we suggest that these are developed, at least in Europe, which has a lot of geological salt strata and potential for this.
Thanks. So there are many other new incoming questions on storage, but I have to work a bit on the older questions, I'm afraid. Let's stay for a second with blue hydrogen, because you mentioned that if blue hydrogen is only useful for the next decade or so, is there a viable business model for developing blue hydrogen? Would that be long enough for investors to make money on their blue hydrogen investments?
Maybe, I mean, that's the thing. I'm not an investor. So Equinor and Shell and all the players that have these technologies, or ZEC Power, have to decide whether it's a viable investment model for them. Certainly Saudi Aramco sees a business model there. But what I would like to clarify on this point is that blue hydrogen, so sort of the main work that it does in fossil gas reforming, that is the 10 to 20 year outlook. But there is a number of not just blue, but also turquoise hydrogen technologies which can take bio-based feedstocks. And we actually see if you have a limited gas reforming / pyrolysis deployment, then in the future you can not even repurpose, but you can fuel switch these facilities to your bio-based feedstocks, which might allow you to attain negative emissions. So the role for them in the future for these technologies will be much reduced, but they still could contribute to sustainability, or at least cleaning up the emissions that they have produced over the 10 to 20 year business life.
Yeah, maybe at this point, I just want to quickly look to Nicola for asking how we're doing with the time, because my feeling is that there are more questions, and if people stay with us, we could actually answer some more of those questions.
Depends if everyone on the podium still has time. Looking to Kirsten now. Would you have another 10 minutes so that we finish at 11:10? Yeah, and whoever is in the audience and has only blocked time until 11 will have the recording online in a few days. So you may be able to watch the last 10 minutes there. So no bad feelings when you have to leave at 11, okay? So we have 10 more minutes then.
Thank you. Gniewomir, very short, I think. Any views on the potential for pink hydrogen in the future? Because we are with those more exotic hydrogen forms?
I would be happy with I'm happy with hydrogen made from any zero carbon electricity, right? Whether European member states decide to allow it is a different issue. I believe that France will go for it, and I think Ukraine wants to go for it, and the Czech Republic wants to go for it, and also Russia is considering it. So, and in the US there is a trial, so it might happen. It would be great if there was a little bit more support for it, but I wouldn't hold my breath for that. But yeah, probably will happen to some degree. It won't be the main one, but to some degree it will happen.
Okay, let's jump to a very fundamental question from the beginning on our framing of no regret applications. Are you really sure that we meet our climate targets in all sectors in the real world, not only in studies, if policy focuses only on no regret measures? Do we have enough time for this real life experiment?
Well, do we have time to be throwing money at applications that later become uncompetitive? I would argue that that supporting applications which are truly no regret provides already enough impetus for to scale reliable hydrogen market. I mean, this was the subject of insight number 4. We're gonna need between 10 to 24 billion euros per annum just for contracts for difference for the steel sector and for PTL quotas for aviation. I mentioned it's not a significant amount of money, but I mean, if you start adding more instruments because this doesn't cover all the no regret sectors that we've mentioned, it's gonna eventually stack up, and it will drive the volumes that are needed to scale up the market. So yes, I don't believe we need to waste money on supporting blending or essentially bankrolling blending or artificially supporting the distribution system operator model for hydrogen and building heat.
Maybe jumping right to that, because somebody's asking, if the gas distribution grid is not required anymore, who will deliver hydrogen to most industry consumers and most CHP plants?
Right, just to clarify. So when we talk about when I was talking about the gas distribution grids, that there is a slight distinction here between low gas pressure networks and higher pressure distribution networks. The higher pressure networks will those that are connected to industrial off-takers and those that have CHP plants as customers, we see them surviving. But those that have households as their main customers, those are the ones that are facing the challenge.
Thanks. Then quick question on transport. I deal with, I think, HGV fleet owners, and they don't want to spend hours charging. They are very clear that for more than 500-kilometer journeys, battery electric vehicles will not be feasible. Currently, a journey from Ireland to south of Italy, they refuel once in Belgium. They want this experience replicated. Would you answer to that?
I would say that insight number 7 agrees with you. Looking at it now, it's the IEA, which has done a survey, says that yes, most journeys above 400 kilometers will be done with fuel cell electric vehicles rather than battery electric vehicles. But for journeys under 400 kilometers, they see battery electric vehicles as the dominant technology, and this is important because 80% of journeys are taken below 400 kilometers. In practice, this means that what I find funny about this is that the energy used by the battery electric trucks will be approximately equal to the energy used by fuel cell electric trucks in aggregate, but there will be 3 times as many battery electric trucks, right? So for battery manufacturers, this represents a big market. For fuel cell manufacturers, this is actually quite a small market. But hydrogen producers will be making a lot of money.
Let's move to a question of imports. One question is, do you have an estimation of how much of renewable hydrogen consumed in 2050 would be produced in the EU versus imported?
I believe this is in the EU. I don't know. We didn't cover this.
Well, I mean, we covered the acceptance question. The key question is, what is the general public willing to accept as renewable scale up in Europe? And many of the answers can be derived from that, I think. So it's,
I suppose it really depends on it really depends on the acceptability issue, on a local acceptance and whether we will secure this acceptance. Because as Insight 9 makes it clear, by 2050, actually, local production is pretty competitive. It is much more competitive than shipping, and it almost starts becoming competitive even with pipelines.
And then a question, will you also speak about the European policies for using hydrogen to make synthetic methane to be used in the gas system?
I mean, if you can use, you can't go that route, but in that case, you need a sustainable source of carbon to make that work, and that sustainable source of carbon will compete with a number of different uses. For example, synthetic fuels, or industrial uses, or negative emissions, or sustainable chemicals, which I reckon will be. And in either case, heat pumps offer a much better deal. Actually, I didn't manage to fit this graph into the presentation, but heat pumps will offer a much better deal than alternative heating technologies.
Maybe following up on exactly that one, there was a question. Thank you. How shall heat be provided for houses in cities without access to district heating and where feasibility of heat pumps is limited?
Well, I mean, I'm not sure what do you mean, what one means by feasibility of heat pumps is limited. Having been to Hong Kong and having seen how they deal with heat pumps, it's despite really small quarters, they managed to fit them in. In the Nordics, despite some of the coldest temperatures in the world, they managed to make heat pumps work. I reckon heat pumps will just work in most places. And for those places that they don't, yes, maybe and where there isn't district heat, in some exceptional cases, yes, maybe there will be some biogas heating or hydrogen heating. But to be clear, these opportunities are very limited.
And if I may add just briefly, if anybody wants to drop us an email on the questions of heat pumps use, there's a great publication on myths around using heat pumps in existing building stocks. Let me know. We can help you with that, I think. So the other questions, there are some more coming in. Not easy to get an overview of that. did I understand this correctly? Importing hydrogen over long distances is more expensive than producing hydrogen in the EU, but importing ammonia or methanol or e-fuels over long distances would be cheaper than producing in the EU?
Yes. Yeah. Essentially, yes. That's the gist. Maybe Kirsten would like to comment on this as well. Would you agree with this gist that the importing hydrogen over long distances is more expensive than producing hydrogen in the EU, but importing synfuels would be cheaper than producing them in the EU?
I'm not a modeler. I read the models. Yes, I think this is right now at least the major punchline in most of the models. Yes, yeah. But I think it's very difficult to look at 2050 and then have an absolute picture. That would be my point.
Maybe if I may add, a different way of thinking about it is, where is the sustainable source of carbon? Kind of, I think, thinking about it the other way around. If you start with your sustainable source of carbon and you end up with, oh, let's do direct air capture, then you have to ask who has the space and the energy to do direct air capture. Is that rather a European solution, large scale, or somewhere else? And maybe you even have another sustainable source of carbon available in some parts of the world where you can easier tap that, produce those synfuels. I think that's part of the story. Let me question on storage. How much do you think access to geological storage options like salt caverns affect early development of green hydrogen?
Well, given the lead times of developing these the storage, it doesn't really affect the early stages, but it really matters in the sort of middle to long
game. Question, and we are approaching the 11:10, I think. Nicola needs to stop me if she thinks we're running out of time here. Hydrogen in cars and light-duty vehicles are a bad idea, according to our table. The UK is already today turning off charging points in people's homes to prevent blackouts. We are at a one-digit percentage of battery electric vehicles in Europe today. How do you take the infrastructure challenge into account?
So it's a really good question, but this is a really good question. Well, the answer is, of course, that the grid will need to be strengthened. And according to a previous Agora publication that modeled the uptake of EVs and heat pumps concurrently, we've seen that the grid reinforcement needed to accommodate electric vehicles and heat pumps, the investments needed would not be out of line with historical trends. So all we need to do is keep investing the same amount of money that we have been investing historically to accommodate this. So now today, of course, the UK might be experiencing this, but that's because we are sort of grappling with this problem that electric vehicles arrived and sort of the charging network, we didn't think about the charging networks. But if we keep investments on track, of course, this problem will be resolved.
Yes, thank you, Kirsten. I think we will then approach the end, actually. But yeah. Kirsten, please.
Yeah, no, I think it's a very, very important point. And this is why I say the one thing is the target models, but we have to think about the socio-economic inertia. And my big concern is, I just say it's a concern. I don't have answers, but I think we now burden hydrogen very much with the shortcomings of electricity. If we say we need the additionality, we see that the infrastructure is now built that could really slow down the development. Just to be precise, I'm not saying I'm just saying that is a very big concern. And also, if you think we are talking a lot about a phase out. And we're seeing that already. If you look into the actual bio right now, it's very clear saying that all the investments around fossil fuels are now on a 1.50 track. But the investments into infrastructure aren't. And the bulk of investment is in infrastructure done by China. And this is really why I keep saying we have to think around energy security as well and competitiveness for European industries. And this is where we really lack the answers, to be honest.
I think this is a great concluding remark from your side, if I may say so. Thank you so much to Kirsten for commenting. Thank you very much to Gniewko for laying out, I think, this rich composition of insights that we have for you. And with that, I would hand over to Nicola. Thank you also, Nicola, for making this possible today.
Thank you very much. And I have to say, the Q&A box was a bit like a perpetuum mobile. Whenever we addressed one of the questions, there was a new one coming up. So we continuously stayed above 20 unanswered questions. So unfortunately, even though we did extend a bit, we were not able to answer all of them. But your questions and remarks are not lost, because we will get a report of all them. And I'm sure that Gniewomir and Matthias will have a look at it. And if you really, really, really want your question to be answered, there's of course still the opportunity to send us an email to webinar@agora-energiewende.de, and I will take care of them and forward them to whoever is able to answer them appropriately. You'll find the presentation on our website, and I believe Matthias is bombarding the chat again. Thanks for ping-ponging today nicely. And then also the impulse paper is on the website. You can find it there. And if you're interested in being kept up to date on our latest publications and upcoming events, I recommend, as usual, to register for our newsletter and to stay in touch with us. And with that, it's 11:11. Sorry for extending a little bit, but I guess it was worth it. Thanks for everyone on the podium, and have a good day, stay safe, and see you soon, hopefully. Bye.